Hello students, in this particular video I'm going to explain about the classification of wind energy conversion in module number 4, wind energy. So we are going to discuss about different types of wind power conversion. Okay, so we will see classification of windmills. Windmills are classified based on several aspects. That first one is based on the amount of power generated. So it is classified as a small scale, a medium scale, a large scale, and very large scale. Okay. So when it comes to a small scale, it is up to 2 kilowatt. So this might be based on the farms, remote applications and other places requiring a relatively low power, okay, which is only about 2 kilowatt. Okay, so it will come under small scale wind power plant. Then medium size machines, which will comes under the capacity is about 2 to 100 kilowatt, where these wind turbines may be used to supply less than 100 kilowatt rated speed or rated capacity. So in several residences or local for local use. Okay, then large scale, which large and very large scale, which is about 100 to more than 1,000 kilowatt, where the large wind turbines are those which is of 100 kilowatt rated capacity or greater, and they are used to generate power for distribution in central power grids. Okay, then about based on the axis of rotation, it is classified mainly on horizontal axis wind turbines, which is called as HAWT, and second one is vertical axis wind turbines, which is called as VAWT. The HAWT and VAWT. These are classified based on the axis of rotation. If it is axis of rotation is horizontal, and the way and the aero turbine planes are vertical, okay, vertical facing the wind, then it is called as horizontal axis wind turbine. Or if the axis of rotation is vertical, the sails or blades may also be vertical, as on the ancient Persian windmills are nearly so as on the modern Darius rotor machine or 7-year rotor machine, which is called as vertical axis wind turbine. So you can able to see there again vertical horizontal axis wind turbines or HAWT is classified into three types, where it is single bladed or double bladed or multi bladed. Based on the number of the blade it is classified. Okay, single blade, double blade or multi blade. And the vertical axis windmill, it is classified as the Darius rotor and 7-year rotor. Okay, based on their constructional feature it is classified. Okay, next it is classified based on the utilization. Okay, it is classified as whether a battery storage, direct connection to electromagnetic energy converter, or other forms of storage, or interconnection with the conventional electric utility grid. Okay, mainly these systems where engineer is seeking to integrate that wind energy conversion system will naturally be most interested, or later that case, but should be aware of wind energy conversion and other options as well. Okay, so apart from this, wind energy conversion is also classified based on the output of the power, whether output is DC output or output is AC output. Under DC output, it requires DC generator and alternate rectifier, whereas AC output it is classified based on variable frequency, variable or constant voltage, variable constant frequency, variable or constant voltage. Okay, and next, based on rotational speed, it is classified as constant speed with variable pitch plates, nearly constant speed with variable pitch plates, or variable speed with variable pitch plates. Okay, and it is also classified based on the direction of receiving the wind, like upwind or downwind, based on the direction, how it will receive direction of receiving the wind, whether it is upwind direction or whether it is downwind direction. These are the classification of wind energy conversion. So we will see upwind. What you mean by upwind wind turbine? So you can able to see in this case upwind. So here upwind machines have the rotor facing the wind. So the rotor is facing the wind. So basic advantage of upwind design is that which will avoid the wind shade behind the tower, and there is also wind shade in front of the tower. That is, the wind starts bending away from the tower before it reaches the tower itself, even if the tower is round and smooth. Okay, so therefore in each time the rotor passes the tower, the power from the wind turbine drops slightly. Okay, so to the basic drawback of wind design is that the rotor needs to be made rather inflexible and placed at some distance from the tower, as some manufacturer have found out their cost. Okay, so in addition to this, the upwind machine needs yaw mechanisms to keep the rotor facing the wind. So you can able to see in this sketch how this upwind machine or wind turbine is going to work. Then a downwind wind turbine. So you can able to see here, it is opposite to the wind direction, is opposite to the rotor face. So downwind machines have the rotor placed on the lee side of the tower. Okay, so they have a theoretical advantage that they may be built without a yaw mechanisms if the rotor and knuckle have a suitable design that makes the knuckle follow the wind passively. Okay, so more important advantage, or one of the important advantage, is that the rotor may be made more flexible. Like upwind, it is not that much flexible, and both in this regard, the weight and the structural dynamics of the machine can be one more advantage. That is, the blade will bend at a high wind speeds, thus taking the part of the load from the tower. Okay, so thus the basic advantage of the downwind machine is that it may be built somewhat lighter than the upwind. That is the main advantage. And then one more advantage of the downwind configuration is that it is very easier to take the advantage of centrifugal forces to reduce the blade root or flap bending moments. Okay, so this is because of the blades are normally coned down vein, so the centrifugal moments or forces tend to counteract moments due to the action of thrust. Okay, so with the because of these advantages, downwind wind will find greater use in case as compared to upwind. Okay.